one. This one's...
We gotta record this.
Oh yeah, we're done with it.
Oh no, I don't think we need to record this.
Debate.
Okay, so
Debate.
the argument is infinity really equal to 1 over 0? Okay, so
Madness, that's it.
you can say the
I don't think so.
limit as 1 over x. X approaches 0.
Positive.
Yeah, from the right is equal to infinity. But the odd thing is that if you approach it, then, and this is probably not like correct to write it this way, but is there.
What did you just write?
For a little quotation mark thing. When you don't want to rewrite.
Okay, so it's the same thing, just two from the left.
Yeah.
Negative.
Yeah, from the left it's negative. It's hard to.
It's just the negative 0.
Oh my gosh. Oh, this. Like
Show it graphically. Show it graphically.
Are those your asymptotes?
Yes, they are.
Technically, yeah. See.
Yep. And that is the mother function.
Holy shift.
These are the asymptotes of that mother function. Oh, I love my bumper sticker so much. Wait, I am doing. Yes, I am doing this.
That's it. That's great.
Okay, now I feel
Except
like
there's
I should be.
4 arrows instead of.
I feel like I should be writing that in a different color because it looks funny.
Kinda.
Looks funny.
Your face looks funny.
That's not what your mom said.
I like the addition of not. That opens up a whole new world. That's not what your mom said.
That was straight.
Okay.
It actually starts curving back.
It comes back.
Yes,
It's
so
not a
right,
function.
Right here we have 2 values.
It's no longer a function.
Nope, it's not. So, yeah, as we're approaching 0 from the left, we're heading further and further down, but as we're approaching 0 from the right, heading further and further up. And of course, 1 over x is basically the reciprocal of x. And that's why I'd argue that infinity and, I guess, negative infinity are the reciprocals of 0.
Any argument?
I do.
Okay, go for it.
Alright, so you could have, it's not really an argument, it's just kind of an idea. What if you had 1 over x squared? You know, because then it would go 1, and then down along this line. Because then, as
Or 1 over absolute value of x.
Or absolute value. That's even smarter.
Because then that would make it so that it's no
That's
matter
what-
what.
Because then, this is wrong. Because then it would be infinity.
But what's odd is that it's not a true reciprocal if you're forcing it to be positive, is it?
Okay, I want to throw my hat into the ring.
Nah.
So, the thing about limits is that...
You need a different color. You get orange.
I get orange? I don't want orange. I
Too
want
bad.
orange too.
Well, that didn't work.
Get enough orange. Okay, so if I have...
Camera
The thing is that limit as x approaches a number doesn't exist if the same thing,
Yeah.
if it comes from the left and the right, you'll find that the limit's not all right. Calculating is going. So if this doesn't equal that, then there's no limit there. It just doesn't exist. So I don't see how this can be infinity. That's my argument. Also, this is undefined. So
By your calculator.
our calculator.
It's
And
undefined.
In pretty much every other area I've encountered, it's been undefined.
And
Let's see if I can-
who bases and what mathematical discoveries were based off the calculators that were given to them at their time? They had to add something to
Okay, so
their
you're saying we
instruments.
should define this just like we defined the square root of -1.
Exactly.
Okay. Well, what
with
if
that
Infinity.
and with infinity. There,
Okay.
it's done.
Well, no, because
Done.
infinity's taken. Infinity means an unbounded quantity.
But they are one and the same in this case.
But they're not, because we just proved the limit
Yeah.
doesn't exist.
I got this. What was I was blue.
Well, I'm saying that there's two. But I'm saying that
Okay, what if we get
infinity and negative infinity are the reciprocals, plural, of 0.
there's two
There's
reciprocals.
two
for
reciprocals.
zero?
Yes, that's my argument.
How many math rules are we breaking for that?
Just one,
There.
maybe two.
Okay, so
What
I mean,
the
I-
F?
It's 8 and infinity.
okay, fair enough.
Kind of. It
Hey,
just,
Okay.
how about this? How about this?
I am
You're right.
intrigued. I am intrigued. I will humor this.
I like his better.
I will humor this notion if you can tell me what in the world we would use this symbol for. Imagine our numbers we use for creating the complex plane. What do we use this defined 1/0 for?
To define 1/0.
For what else then?
Well, if you have like
As a more interesting way of saying writing DNE.
equals 5 super infinity.
Okay.
So it's a whole new counting system, and this, so that'd be Aleph 5. There.
You want to
Any
contribute?
ideas,
Haley?
Haley?
I'm not getting into the middle of this. Your guys' thing.
Okay.
Would it be the same as 5 times this? Would the constant still apply?
Isaac
Well, of
Parker,
course.
You have
Yes.
a
Okay.
ballpark
Why?
on
Because you
Why
can,
not
sim-
split?
you can like, I
Bella,
hate to
you have a
factor out the
ballpark
5
on
by
101?
saying,
Oh, okay.
you
You
can,
factor out. Right.
you can factor out writing 5 there, like 5 times 1/0.
1/0. Okay.
See?
That's fair.
Just like that.
I see your point.
But what about like instead of writing it like this, could you write it 1/infinity equals 0?
Is that true?
If I limit, right?
1/x as x approaches infinity? Well, yeah, definitely, because that means. Okay, so what are you going to prove with that?
I don't know.
Oh, but here's my argument to that. If that's true, that means 1 equals 0 times infinity. And if we look at that thing, that means 5 equals 0 times infinity. And so does pi, and so does everything else in the world.
And so it breaks the
No,
the
therefore-
0 identity rule
Yeah.
of multiplication.
Therefore, 0 times infinity equals super infinity. If I could draw it.
What the?
I went to draw
It's that
infinity.
simple, everybody. Yeah.
Which oddly looks like a caterpillar.
strand.
Hey, that is not a double helix.
Yeah, I know.
That is a 2-dimensional representation. It may look like a 2-dimensional. That is a. That looks like an ant.
It is, yeah, it's an ant with an extra set of legs.
So you're saying that
0 times
Spider
infinity
ant.
equals.
an ant with an extra set of legs,
It's a spider ant.
spider ant.
Spider ant.
Spider.
Oh gosh.
So, I think what we've conclusively proved here today is that we can't keep on track for more than 5 minutes. Where are we at on the count?
Hey, actually, we've kept track for a solid probably 7 minutes.
Okay.
We're about 9 minutes in.
So, I mean, what are we going to say about this? Does infinity equal 1/0?
Or does one
No, this equals 1/0.
Okay, so we're saying that 1/0
We're-
is still undefined, but if we want to,
we define it as super infinity.
please don't kill us, mathematicians. We're just saying stuff.
Math gods.
We're all ignorant high schoolers.
It's an interesting debate. What do you think?
And as we post this on YouTube, someone's probably gonna correct us.
Yep.
Yep.
Send
Play
us-
more! Let it begin.